Welcome back to Daily Dose of Space. Today, we are looking at three unfolding space events that, together, paint a remarkable picture of how dynamic our solar system really is. A newly discovered interstellar object is tearing itself apart. The Sun has launched a rare Cannibal coronal mass ejection heading toward Earth, and observers in Australia just witnessed some of the brightest auroras seen in the Southern Hemisphere in years. Each of these stories stands on its own, but when you connect them, they reveal just how much activity surrounds us at any given moment. So, let's break it down piece by piece. The interstellar visitor breaking apart, 3I Atlas. When astronomers confirm that an object originated outside our solar system, it immediately becomes a priority target. We've only seen two interstellar objects before, 1I Oumuamua in 2017 and 2I Borisov in 2019. So, when the Pan-STARRS Observatory flagged a new hyperbolic object, now officially designated 3I Atlas, it caught global attention. What makes 3I Atlas particularly interesting is what's happening to it right now. Based on recent observations pulled from the Minor Planet Center and the global Meteor network, astronomers are confident that the object is experiencing rapid structural fragmentation. In simpler terms, it's breaking apart as it travels past us. This isn't unusual for comets within our solar system. Sublimation, the process where ice turns directly into gas, can create internal pressures. But 3I Atlas is special because it's being exposed to the Sun for the first time in its existence. Its material has never been heated by a star before. That means the ices inside it may be incredibly volatile. Recent reports describe its light curve as unstable, showing sudden drops and rebounds in brightness. That typically indicates that chunks of material are separating, exposing fresh surfaces to sunlight and causing rapid outgassing. This is likely the same kind of behavior that destroyed Comet C 2019 Y4 Atlas, which shattered into dozens of fragments back in 2020. But with 3I Atlas, we're watching this process unfold for an object that originated far beyond the Sun's gravitational influence. What's fascinating is that fragmentation helps us. Every exposed part of the object reveals new chemical signatures. Spectroscopy over the next few weeks will tell us what this thing is made of, how it formed, and how similar or different it is from anything in our own solar system. We've had less than 10 years between our first and third interstellar visitors, which suggests something important. Interstellar objects may be far more common than we once thought. 3I Atlas won't come close enough for us to image in detail, but every moment of its decay gives us more data. This is one of the rarest types of astronomical events, a chance to study material from another star system as it falls apart within ours. The Sun just launched a Cannibal CME. While astronomers track an interstellar object breaking apart, something much closer to home is stirring. Our Sun. Solar observatories confirmed that earlier today, the Sun released multiple coronal mass ejections, massive eruptions of charged particles. The first was relatively slow. The second, launched hours later, was significantly faster. And as it left the Sun, it caught up to the earlier one and absorbed it. This produces what scientists call a Cannibal CME. A Cannibal CME is essentially two eruptions merging into a single, more energized shock front. These are rare compared to normal CMEs, but they're also more powerful and more structured by the time they reach Earth. According to data from NOAA's Space Weather Prediction Center and NASA's Solar Dynamics Observatory, the combined CME is directed toward Earth with an estimated arrival time within the next 24 to 36 hours. Forecasters expect a G2 to G3 geomagnetic storm, moderate to strong on the official scale. For most people, this doesn't pose a threat, but it can disrupt satellite communications, GPS accuracy, HF radio traffic, and, in extreme cases, electrical grid stability. We're not looking at a 1989 Quebec blackout scenario. Nothing close to a Carrington event, but the impact is still significant. Space agencies and satellite operators are already preparing for elevated particle flux in Earth's magnetosphere. What's especially interesting is that Cannibal CMEs tend to generate stronger auroras because the magnetic field they carry is more coherent and more likely to reconnect with Earth's magnetic field in a powerful way. And that brings us to our third story. Australia just lit up with massive auroras. Whenever a geomagnetic storm reaches Earth, the most noticeable effect for the general public is auroral activity, the northern and southern lights. And last night, southern regions of Australia experienced some of the brightest auroras in years. Observers in Tasmania, Victoria, and even areas traditionally too far north for strong auroras reported vivid reds, greens, and purples across the sky. The Bureau of Meteorology has confirmed that the geomagnetic storm responsible was associated with a CME that arrived earlier than expected and with stronger magnetic parameters than predicted. What makes these auroras special is not just their intensity, but their geographic reach. Seeing lights this strong from latitudes above 40 degrees south is uncommon. It highlights just how active the sun has been during its climb towards solar maximum. If tonight's Cannibal CME arrives with a southward magnetic field, meaning it connects well with Earth's magnetosphere, we may see another surge of auroras, potentially visible even at mid-latitudes. This solar cycle continues to surprise forecasters, producing some of the strongest and most frequent storms of the last decade. And with at least 2 years left until the sun reaches peak activity, more events like this are almost guaranteed. So today we have an interstellar object fragmenting as it passes through our system, a powerful solar eruption heading straight toward Earth, and brilliant auroras illuminating the southern hemisphere. Each story is independent, but together they remind us that our solar system is constantly in motion, filled with incoming travelers, explosive stellar weather, and atmospheric reactions visible from the ground. It's a lot happening at once, and none of it is unusual. This is what normal looks like when you zoom out to the scale of the cosmos. Thanks for watching Daily Dose of Space. If you enjoy staying updated on real, verifiable events in astronomy, be sure to subscribe, and I'll see you tomorrow with the next story from our universe.